Welcome to our video on understanding stroke volume and its relation to end-diastolic volume, end-systolic volume, and contractility. In this video, we will explore the various factors that influence stroke volume and how it affects the heart's pumping capacity. So let's get started. Before we dive into stroke volume, let's understand some key terms. End-diastolic volume, EDV, refers to the volume of blood in the ventricles at the end of diastole or relaxation. End-systolic volume, ESV, on the other hand, is the volume of blood left in the ventricles at the end of systole or contraction. Stroke volume is the difference between EDV and ESV, indicating the volume of blood ejected from the ventricle with each heartbeat. So SV equals EDV minus ESV. Now let's explore the other factors that influence stroke volume. The first factor to consider is preload, which refers to the amount of stretch on the ventricular muscle fibers just before contraction. Changes in preload affect the stroke volume through the Frank-Starling mechanism. This slide explains the Frank-Starling mechanism. So, an increase in the venous return will lead to an increase in the EDV, which leads to an increase in the preload, which results in an increase in the stroke volume. Moving on, let's discuss afterload. Afterload is the pressure that the ventricles must overcome to eject blood into the aorta. Changes in afterload can affect stroke volume by altering the ventricle ability to eject blood and influencing ESV. When afterload is increased, for example, due to increase in aortic pressure, the stroke volume decreases. This is because the ventricle needs to generate more pressure to overcome the higher afterload, resulting in decrease in the amount of blood being ejected with each heartbeat. Additionally, an increase in the afterload causes ESV to increase. Lastly, let's focus on ventricular contractility, also known as anatropy. Contractility refers to the heart muscle ability to contract and develop pressure during systole. Changes in ventricular contractility directly affect stroke volume. When contractility increases, such as through sympathetic activation of the heart, stroke volume increases and ESV decreases. This means that the heart pumps out more blood with each contraction, resulting in higher stroke volume. To summarize, stroke volume is influenced by three main factors: preload, afterload, and ventricular contractility. An increase in end-diastolic volume, EDV, leads to an increase in stroke volume through the Frank-Starling mechanism. Increased afterload decreases SV and causes an increase in end-diastolic volume. Moreover, an increase in ventricular contractility increases SV and reduces ESV.